Okay, how do we calculate out this first one? What do you need to know to calculate out these parts per million questions? What's the equation look like? So I need mass of both the solutes and the solution, and all I have right here is the volume of the water. So is there something I could do to give myself mass? Yeah, since the density is 1, I can convert this into grams via turning the liters into milliliters. So you're going to have 500,000 milliliters, and then the density is 1 gram per milliliter, so you end up with 500,000 grams. And so I don't know what my mass of my PB is, but I know that this is 500,000 grams, and times 10 to the 6th equals 7 parts per million. So then the mass of my lead is going to be, what is that? 7 times 500,000 divided by 1e6. So 3.5 grams of lead. So entropy, S, unit, joules per mole, Kelvin, and it's measure of disorder of a system. Okay, so then enthalpy is an H, and it's usually kilojoules per mole, and it's and then Gibbs free energy, G, it's also kilojoules per mole, and it's spontaneity, how spontaneous, or if a reaction is going to be spontaneous or non-spontaneous. Cool. Alright, so I've got an endothermic reaction, and it becomes more ordered. Is this going to be spontaneous? It can't possibly be spontaneous, right? So, no. Yep, it's going against thermodynamics. Should be losing energy and becoming more disordered if you want it to be spontaneous. So what do we need to do with this next calculation?
Find out how many milliliters of the qualified bond concentration you have.
Do I not have the same homework you have?
Yeah.
I don't?
You know?
Cool.
Our next question is explain.
Well, that's different. Oh yeah, there we go. That's you.
Yeah.
Yeah.
Nice. How many milliliters? Okay, so what do you want to do?
Use the dilution equation to figure out how many.
I'm okay with that. So, M1, V1, M2, V2. So what pieces of information do I know?
Like 12.1 for M1.
So I have 12.1 molar. Okay. What else?
You want that out, it doesn't matter.
I don't care about that. Yeah, that's fine. You can do that. So V1 is equal to, and what do we got? Anybody? 0.25 times 0.5 divided by 12.1. Is that really it? 0.0103 liters. I need to get rid of this other Word doc. Don't save. This didn't need to be converted into liters. Doesn't matter. So I'm just gonna convert it back, and we're gonna say the volume is 10.3 milliliters. Okay, so how I would make this is add 10.3 milliliters of 12.1 molar hydrochloric acid to a 500 milliliter vol flask. Fill near line, and then you fill to line with a dropper. Okay. Purpose of the catalyst? Speed up a reaction. That's all it's supposed to do. How does it do that?
Make sure these orient.
Yeah.
More surface area.
Line stuff. It's not more surface area. Line stuff up. It's about orientation. Okay. What are the orders for each of these reactants? All right. So if I look at here to here, A goes up by 2, B goes up by nothing, and the rate goes up by 2. So what order is it with respect to A? First order. All right. And then the other way, if I go from 1 to 3, I got 0 here. Here it goes up by 2. And what happens here? It goes up by 4. So 4 to what goes right there? 2. So it's second order with respect to B and first order with respect to A. How about for this one? So that goes up by 0. What's this go up by? Is everybody okay with that? It's not by how much it goes by up by, it's by what factor it goes by. So if I take 2 and multiply it by 1.5, I get 3. So then how much does this change? Also 1.5. If I take that, if I take that 0.26 times 10 to the negative 9th and multiply it by 1.5, I get 0.39 times 10 to the negative 9th. Okay, so that makes A first order. And what about B? So nothing happens here. What about here? This goes up by 3. And then what happens here? This goes up by like 10.3. So I got 10.3 and I got 3. And what goes right there? That would be 27. So no. 3 cubed to be 27. I'm gonna put a 2 right there and say it's second order and say this is stuff that people do and people make mistakes. And so when you do this lab next week, you're not gonna get straight, easy, awesome, very dividable numbers. So this is second order because that 10 is close enough to the 9. And if you wanted to verify that it was second, I mean, what are you gonna do? If somebody's actually trying to calculate what the order of this reactant is and they're the first person to do it, they're gonna do this 150 times and average it out, and it should be second order.
How come A was first order for
Because when I raised the concentration by 1.5, the rate went up by 1.5. So,
Usually doubled it before, doubled, the result doubled, this one went up by 1.5.
so
Like this one.
my rate, it changed by a factor of 1.5, right? So I also changed my concentration by a factor of 1.5. So what exponent do I put there to make them equal to each other? Well, 1. Okay. Okay, so give me one of the 4 factors. Say again? I didn't hear. Temp, okay. So temperature is definitely something that plays a role. How about something else?
Pressure.
No.
state.
Okay, state. Next,
Concentration.
concentration. Next,
Presence of catalyst.
catalyst. So how do I relate the first one to the collision theory?
You got enough energy.
Yeah, this requires energy, and temperature is a measure of the energy of the particles. And state, it's about colliding, right? What about concentration?
Sliding.
Again, colliding. And catalyst?
Orientation.
Okay.
The temperature be related to colliding?
Just because they're moving faster doesn't mean they're more likely to run into each other. The temperature is about them, when they do hit each other, they hitting each other hard enough to actually react. What is that energy being used to do? When I increase the temperature, how is that assisting?
Break the bonds.
When those two things run into each other, somebody needs a bond to be broken, and so a bond gets broken. If they just tap on each other, then they're not going to have enough energy to actually break the bonds that they already have. So you hit them together hard enough, their original bonds break, so then I can reform the regular or the new bonds. Okay.